Good day. This is a continuation of Introduction to Kinematics, and today I just wanted to spend a couple of seconds to discuss some of the math that we'll be using in this course. And you've taken these subjects, I'm sure, so I don't really need to spend an awful lot of time. But I just want to be sure that you do know that these will be our tools that we're going to use for this class. Now, just a quick review. We're going to use right triangle trig, and I want you to be sure that you're familiar with the geometry of the right triangle trig and the application of the symbols. So angles are given in capital letters and sides are given in small letters. And of course the angle that is opposite the 90-degree angle is called the hypotenuse. It's very important to understand these relationships and know what formulas you can use with this type of triangle. And what you can use primarily, if you know all the sides, you can use this relationship, c squared equals a squared plus b squared. That's the Pythagorean theorem. And of course, you should be very confident in being able to rearrange this formula in order to find either C, A, or B. And get yourself some practice and make sure that you can do this quickly. Also in right triangle trig, and only in right triangle trig, can you use these functions. Now, there are relationships between the sides that we can use. If we note two of the sides and the hypotenuse, we can find an angle. Now, I'm using the symbol theta for an angle, and it could be either this angle here at A or this angle here at B, depending on what your problem is. So, I'm confident that you know what your calculator is capable of doing, and you're able to put figures into the calculator. So just try to remember this relationship. You should probably have this memorized by now. The angle of the sine of the angle is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So with the use of your calculator and your ability to visualize triangles, and remember this is strictly for right triangles, it cannot be used for oblique triangles. So there will be many right triangles and also oblique triangles. In oblique triangles, we can use these two tools. And these tools, again, depending on what you're given and what you need to find, are very useful. Now, the side A opposite the angle A over sine A is equal to B over sine B, which is equal to C over sine C. So in this situation, you take a pair. You just take a pair, either A or B, or A or C, or B or C, whichever. You don't use all three of them together, obviously. You just take a pair. And then you can, if you know three values, you can find the unknown. Now, depending again on what you know in the triangle, you can use the law of cosines. And this is a very powerful formula, but again, where most students seem to have trouble is to being able to input this into your calculator and being able to manipulate these numbers so that they come out right. Also, you should have the ability to solve any one of these, the cos for angle C. You should be able to find A or B using that formula. Now, attached to this lesson is a group of documents that you can use. Some of them are conversion charts, some of them are charts that actually make these equivalents, and so that you can use those as a tool to help you get through these problems. So I would look at those documents to make sure that you have that handy. Now also in kinematics, of course, we're not just going to use the plain raw math, we're going to have to apply it to word problems. And I've noticed that some students in the past can't really relate the actual side of a triangle to what it might be. So I put some words on the board that probably will be helpful for you to be able to recognize what the side of an angle might be. So for angular measurement to the horizontal, in engineering and in architecture, we use words such as incline or decline. Incline would be a line going upward. Decline would be a line going downward. So in a situation where we say incline or decline, be sure that you know which direction they're going. Elevation and depression. Elevation is usually up. Depression is usually down. So if you see those words, then you'll know how to apply that math to those words. Now in architecture and in civil drafting and civil construction, we use words such as slope, pitch, and grade. And these are expressions of the angle to the horizontal. And slope would be an expression that is used in degrees. Pitch is a ratio. And grade is a percent. So when you're trying to solve those kinds of problems, then you have three other ways in which you can give your answer. Now, as far as linear measurement is concerned, vertically, words such as plumb, upright, and erect would be an exact vertical line. Now, horizontally, words such as level or flat would be used in a problem. So you should be able to associate those words with what you need to find in a problem. There are others, but these are the ones that I find students have had the most trouble with. Now, as far as units of measure in this course, there are linear, angular, there's time measurement and speed measurement. And when you give your answers, you should be always ready to put in the proper units in your answer. So here are some examples that you're all familiar with, I'm sure. Feet, inches, and millimeters. Most problems will end up with millimeters. Angularly, we have a revolution or radians, and degrees, minutes, and seconds. Those are all units of measure that you'll find constantly through problems. Now, as far as time is concerned, you're familiar with that. Hours, minutes, and seconds is not worth reviewing, but just be aware that there will be time involved in the problem. And speed, we're looking for linear speed, and these relationships will appear. Of course, you're familiar with MPH, which is miles per hour. M is feet per minute, or it could be IPS, which would be inches per second. These are just examples of some of the units that you might see for handling time and speed. Now, speed for angular will be either in RPM, which is revolutions per minute, or rads per second, which is a possibility that may occur. Now, in addition to knowing what these terms are, you're going to have to be able to convert from one unit of measure to another. So you should be prepared to recognize what the relationships are between seconds and minutes, degrees and minutes, radians and degrees, and so on. Those we will discuss later as we get into this class. So there you have it. I would get to review your trig, get familiar with the parts of a triangle, understand what the units will be as they come in this class. So I think we're ready to do some problems. So let's get at that, and this lecture is finished. Thank you very much.